In a previous video, we did a lot of surface mount soldering of this section of the circuit board. All these surface mount parts we assembled using a soldering iron and solder wire. There's nothing wrong with this. It can be very reliable, but it takes a lot of skill and things can get pretty small and pretty tricky. There are other ways to do surface mount soldering, and one of them is to use paste and a stencil. You can stencil the paste onto the circuit board using a laser cut stencil. When you get your PCB manufactured, you can also get these laser cut stencils created, and the apertures in this stencil are each of the pads of our surface mount parts. So you can see this large hole lines up with where the regulator large tab would be. This is a really fast and reliable way to assemble surface mount parts, and it's how it's done in industry. We're going to stencil the paste onto this part of the circuit board and then reflow it with a hot plate, or in this case, a hot air gun. If you're doing more than one board, it may be worthwhile creating a bit of a jig. You can use other unpopulated circuit boards to create a jigging system to hold your circuit board directly underneath that stencil, exactly where it needs to be. That's what I'll make now. I'm finding the rough alignment by sliding my board under the stencil. I've got these shiny metal pads poking through the holes in the stencil. So that is well aligned. To help me keep it aligned though, I'm going to create a jig. Carefully peel the stencil back and tape down this circuit board material. And I'll use an unpopulated board as my other side. Check the alignment is still good. Not super pretty, but it'll do. Now we can align our circuit board into the bottom left corner, and we should have pretty decent alignment. We're now going to charge the stencil with solder paste and squeegee it across using a metal scraper. Like a paint scraper will do just fine, as long as it doesn't have sharp corners. You don't want to drag sharp gouges into your stencil. I'm using lead-free solder paste today. If you're using leaded solder paste, you definitely want to wear gloves because the paste makes the lead a lot more bioavailable, and certainly wash your hands after using it. I'll charge a little bit of paste onto the stencil. Align the squeegee, and then squeegee the paste. Keep firm, even pressure, and then peel back without sliding the stencil. You might be able to make out the solder paste that is on those pads. You should be able to see that the grey is a fair bit duller than the other shiny pads around it. The alignment is okay. If you see some shiny metal poking out the side of your pads, that might mean that your alignment isn't spot on. But for the sizes of components we're working with, this is super good enough. Set the stencil to one side. And now instead of populating and soldering the parts one by one, we can populate all the surface mount parts together in a similar fashion to before, except this time we're just going to drop them onto the solder paste, and the sticky solder paste is going to hold the part in place until we solder everything at once. Here goes that diode. I can just nudge that into the paste, and that's sitting quite happily. I'm just going to populate all these parts, and I'll see you when I'm done. The parts are now populated and we're ready for reflow soldering. Now you can see in this case, it's a really good argument to only have components on one side of the board. You could imagine if we had parts on the underside of the board, it would make the first squeegeeing step very challenging. I've got my hot air blower up to temp, so I'm just going to slowly solder these parts. That was pretty fast. There you have pasting using a stencil. This is definitely preferred if you have many parts to solder or you have many boards to assemble, because with that stenciling jig, you can just paste board after board very quickly and precisely. It's quite fascinating to see the surface tension draw those parts into place. That's always very nice. This isn't a very complex board, so it's not really necessary to use a stencil to paste it. There's not very many surface mount parts and all the pads are very forgiving. So instead, you could use the solder paste with a dispensing nozzle. You can dispense it directly like this, or you can fit these into an air dispenser where this will snap into a tool that applies air pressure onto the plunger or onto a different component inside the syringe. And you can operate it with a foot pedal or like a pen button, and that can be used to dispense very precise amounts of solder. Syringing directly is certainly not preferred. It's not very well controlled, but for something simple and with large pads, it works just fine. Here's what that looks like. I'm going to charge the nozzle and then just gripping it quite tightly, I'm just going to apply gentle pressure and paste each pad individually. And you can see this is pretty fast. This is probably faster than setting up that stencil. For a circuit of this complexity, you'd probably just hand dispense. Of course, the trade-off here is that this is much less precise in both the location and amount of solder that you can dispense. A stencil is very, very well controlled because it's the thickness of the stencil that determines how much paste is going to be left on the pad. Here, I've probably overpasted some pads and underpasted some others. It can be quite tricky to dial in the exact amount of solder that you really want. This is probably a viable method for 0805 and upwards. 0603 if you're really dialed in. And of course, you would just hand place the parts as we did before and then reflow solder. Hope you enjoyed.